Hey guys, it's Mr. Noise again. Today we're gonna talk about energy. The first video was more about work, and now we're gonna talk about energy. Now, can you tell me what the definition of energy is? The ability to do work. Energy is defined as the ability to do work. If you have energy, you can do work. You can speed something up, or you can slow it down. That's what the first video talked about. Okay, in this video, let's talk about something you probably know already before you took physics, if you took physics, and that's energy, types of energy. So basically, there's two categories of energy. There's potential energy, and then there's kinetic energy. Okay, kinetic energy is the energy you have because you're moving. That's the easiest one to understand. So it's the energy you have because you're moving. If you're at rest, you don't have kinetic energy. You might have potential, but you don't have kinetic. So it's moving energy. A car, moving. You moving. You have kinetic energy. I'm not going to even go into the equation because this is not physics. This is like an application of physics, but without all the math yet at all. Okay, potential energy would be energy you have because of your position, or we often call it stored energy. Stored energy. It means you have the potential. I better not explain it. So it's stored energy. And a better definition would be the energy you have because of your position. Energy because of position. Oops, sorry. An example of that would be gravitational potential energy. If you were on top of a building, holding a ball off the edge, that ball would have a lot of position off the ground. Right here we say there's zero potential energy level. We indicate the zero potential energy level with that with kind of a dotted line down there. So that'd be zero potential energy. And because of your position off the ground, you have lots of potential energy there at the top. So right here, we got lots of potential energy. The higher it is, the more energy you have. Think about it. The higher you fall from a height, the more hurt you're going to be when you hit the ground. Okay, so other examples of potential energy. Can you think of anything? Well, spring potential energy or elastic potential energy. So we could call this here. Let's do another page. Run out of space here. So we're thinking of examples of PE, potential energy, gravitational potential energy because of your height, position off the ground. I'll just say height, okay? Because your height off the zero potential energy level, which we usually call the ground. Ground. Okay, we also have elastic potential energy, also called spring potential energy. Spring potential energy or elastic potential energy. And that's the energy you have. Here's a spring. If you compress that spring, squish it together, or if you, what do you call it? You pull apart, pull on either end, you cause the spring to contract. I'm sorry. You cause the spring to pull farther away from. So there's a unstressed spring right there, that first picture. So if you pull both ends of it and stretch it out, that has a lot of potential energy. Or if you squash it by pulling, by compressing it, or by pulling the two ends apart. Okay, well, the position is from the rest position, like right here. That's the unstressed position. So you can see how much further it's stretched. So the distance that it's stretched from its rest position, let's call that the rest position right in the middle. The more of that there is, the more elastic potential energy you have. Or, you know, from here to there, the rest position would be a compression kind of deal. So spring potential, it doesn't have to be a spring, it could be like a bouncy ball. When a ball hits the ground or a racket, it smushes and it's stressed. Its position is now different from the rest position. So it stores energy and it tries to spring back to the rest position. Okay? There's all kinds, in chemistry, we have chemical potential energy. And that's the energy stored in the bonds, in the chemical bonds. So I'll say chemical potential energy or chemical bond energy. You know, like in water, the bond between hydrogen and oxygen. So there's energy in those bonds, as you recall from chemistry and probably biology when you're talking about energy molecules like ATP. Okay, there's also electric potential energy. Oops. I'm going to go to another page, continuing our idea of types of potential energy. There's electrical potential energy, EPE. That's going to be important in this course as we talk about making electricity technologies. And so that's EP, electrical potential energy. And simply speaking, you have a negative charged plate, lots of electrons. The electron will have a higher, it's a negatively charged plate, it'll have a higher electrical potential the bigger the force of repulsion or attraction on it. So right here, it's far You know, unlike charges repel, right? Like negatives repel. So right here, the force is repulsive. But right here, the force is really repulsive. The bigger the force acting on the charge, the stronger or the bigger the electrical potential energy. You can do the same thing with a positive particle or unlike charges. Let's say, which case would the positive particle have more electrical potential energy from the negative plate? Okay, when it's close to it or when it's far from it? Well, where would it feel the greatest force? When it's closer. Just like a rock would feel more weight when it's closer to the earth than when it's far away from the earth. So this would be a big force of attraction, and the plate would be attracted to the positive as well. I could draw that like that. Okay, but it would mess up my picture a little bit. Okay, but when it's out here, far away, there's attraction, but it's not as much. So this is less EPE than it was when it's closer. Okay, I just blew that. I just made that. Okay, so I'm gonna just go back. Let's erase all this. I'm not gonna go into all those details. Okay, so another type of electrical potential energy that we can talk of is electrical potential energy. And it has to do, I'm not going to go into details of it, has to do with the potential energy of a charge. Because of its location to another charge. Because of its position to another charge. So for example, simple example, what if I had a negative and a negative, and a negative and negative, like electron farther apart? Which one would have more? Which case 1 or case 2, would the electron have more electrical potential energy because of its position? Where would it feel the if you released it, it would spring away the fastest? Yeah, number 1 has more EPE. This has less EPE, respect to each other. Now you can do the same thing with positive particle. I mean, with unlike charges. This was with light charges. And the same thing would be true with positive and positive. Now, what if you had unlike charges? So what if we had a plus and a minus right next to each other? Then in case 3, okay, let's call that case 1. And then in case 2, I had a positive far from a minus charge. Now, which one, when released, would smack into the other with a higher energy? Think about it. Which one, when you released it, would smack into the other because they're attracted with greater energy? Well, the answer would be the one that's farther away. That's like a rock falling to the ground. The farther it is away from the Earth, the faster impact speed it will have when it hits the Earth. Okay, so if the rock is right above the Earth and attracted to it, it will hit the ground, but not with as much speed at all. Okay, so you don't really need to know those details in this course, but it's nice to have kind of idea what electrical potential energy is. The more electrical potential energy, for example, a battery has, the higher voltage it has. So you've heard that word, voltage, before. Voltage and electrical potential energy are not the same thing, but they're directly proportional. Okay. Excuse me. Okay, so talking about some other types of potential energies. Make another page. So we talked about gravitational, spring, electrical, nuclear potential energy. Oh wait, before I talk about that, chemical potential energy is just like spring potential energy, unless I've talked about it already. I'm getting tired, sorry. Yeah, I talked about chemical potential energy already. Okay, so let's talk finally about nuclear potential energy. And that's the energy. I'm going to just be really brief. This is the energy stored in the nucleus. You know what I mean by not a cell nucleus, but an atom nucleus. Now, just briefly, the nucleus contains protons and neutrons, right? I'll put a 0 for a neutron. Now, look, you got these positives the protons really smushed together with the neutrons. That is an incredibly repulsive force. It wants to blow up. But when protons and neutrons get close to each other, the special force kicks in, the nuclear force that's stronger than that repulsive force. And so the special nuclear force smooshes it all together and keeps the nucleus intact. Now, in nuclear, when you have an atomic reactor, fission reactor, or fusion reactor, we release that energy that I'm showing by the pink arrows. And that's the most incredibly concentrated energy possible that we could, think of. Okay, so that's all I can think of about different kinds of potential energy. Now, there's kinetic energy is basically anything that moves. The molecules, when big objects move, you can think of anything, a leaf falling, has kinetic energy. Anything moving has kinetic energy. Now, example of kinetic energy that's kind of cool that people forget is our molecules when they're heated. You know that when molecules heat, as the temperature goes up, the speed of the molecules gets quicker. You know that from chemistry. The speed of the molecules increases as the temperature goes up. So does the pressure and all that, but whatever. So the warmer you get that, the more they vibrate back and forth. As molecules vibrate back and forth, the faster they vibrate, the hotter they get. So the hotness of something, the heat of something, if you have something with molecules moving, is a form of kinetic energy. So frictional heat, thermal energy would be a kind of subtle example. Thermal energy or heat. Due to quickly moving molecules. Then, you know, as the temperature goes up, the speed of the molecules go up. Okay, I'm not being able to write that in this tiny spot. So I meant to say quick moving molecules. Okay, there's another form of energy. Well, you can even say sound is a form of kinetic energy, sound waves, because we'll have energy like that. Electricity can turn into sound, like speakers, audio speakers, headphones, etc. So let me write that. So another form of kinetic energy would be sound waves. You can't have sound waves unless the medium's vibrating. So KE example, besides the obvious ones like cars moving, birds flying, would be sound waves. And sound waves are due to the molecules vibrating back and forth like this. I'm not going to go into that physics at all. But without the medium vibrating back and forth, like an individual molecule going back and forth, like back and forth at a certain frequency, without that matter moving back and forth, matter having kinetic energy, you would not have sound waves. And finally, a type of energy that is important in this course, but isn't kinetic or potential energy, is what some books call radiant energy. Radiant. I call it electromagnetic. Electromagnetic energy. And as you recall from physical science or physics, all light, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet, all the colors receive visible light. Remember the spectrum? That's from low energy moving. I'll tell you that in a second. I'm not going to even go into that, okay? I have to hold back. Okay, so we got Roy G. Biv. We got ultraviolet. These are all types of energy that don't require moving molecules. They're caused by moving charged particles. Charged particles vibrating causes these waves, like electrons vibrating at a certain frequency. Okay, UV, what comes next? X-rays, then gamma rays. Gamma is given a symbol like that. Those are the highest energy rays there are. Again, these are radiant energy or electromagnetic energy. Then lower energy would be, this is Roy G. Biv right here, visible light. Below red in energy is infrared. That's really heat waves. They're given off by moving molecules. Not the hot material itself, but the waves that are given off by the heated material, like from the sun or from a hot stove. And then you get all kinds, you get microwaves, and these are going in decreasing order of energy, decreasing amounts of energy. So we got microwaves, one word. Then we got radio waves and television, and then TV and cosmic waves. Okay, whatever. But the point is, this is kind of weird. This is energy moving. It's not potential energy. It's not kinetic energy. It's energy wave due to some charged particle vibrating at some rate. And as it vibrates, it produces these kind of waves. Okay, so that's basically all I want to do here. The next video, short video, will be about energy conversions. How energy can change from one form to another, which is very important in this course, because we get energy sources and then we use them to convert that energy to do work, or to convert it to a different other kind of energy that's more useful to us. So we'll talk about that throughout this course. Okay, so that's the end. You guys have a good night or morning, whatever. And here's my Zoom video.